Your CPU is currently doing billions of operations right now, even if your PC is just sitting there. But what is it actually doing, and how does a tiny little chip make your entire computer work? Well, let's open it up metaphorically and see what's really happening inside. A CPU, or Central Processing Unit, is a small square chip made of billions of transistors. These transistors act like microscopic switches that flip between 1 and 0, the basic language of computers. Every app you open, every game you play, every tab you click, the CPU is constantly flipping these switches to perform calculations and make decisions. Think of it like a super fast decision machine. Your keyboard says A, the CPU decides what to do with that. Your game says render this frame, the CPU then coordinates the whole process. Now every CPU follows a simple but powerful loop called fetch, decode, and execute. Fetch, the CPU, grabs an instruction from the RAM, decode it, then figures out what the instruction means. Then it executes it, performs the action, math, logic, moving data, or controlling hardware. This cycle repeats billions and billions of times per second. That's what your CPU clock speed, like 4.2 gigahertz, actually represents 4.2 billion cycles every second. This is why even the simple tasks feel instant, because your CPU is doing thousands of operations before you can even blink. Early CPUs had one core, one worker, doing all the tasks, but now modern CPUs have multiple cores, which means multiple workers inside of the chip. One core equals one worker. 4 cores equals 4 workers. 8 cores equals 8 workers, and 16 cores equals 16 workers. Threads are like virtual workers that help each core handle more tasks at once. Now, more cores equals better multitasking, like video editing, streaming, and heavy workloads. The faster single core performance, the better gaming and snappy everyday use is. This is why a 6-core CPU can feel faster than a 16-core CPU in certain games, because the game only uses a few cores efficiently. The CPU doesn't store most data, it actually requests it from the RAM. So here's the flow. The CPU sends a request through the memory's controller, the RAM, finds the exact row and column where the data lives. The RAM then sends that data back to the CPU then processes it and requests more. This back and forth happens millions and millions of times per second. Now, if the RAM is slow, the CPU waits. If the RAM is fast, the CPU stays fed with data. This is why RAM speed and latency matter. They directly affect how efficiently the CPU can actually work. Now, inside of a CPU, there are several key components. The ALU does math and logic, registers tiny storage locations for quick access. Then the cache, super fast memory built into the CPU control unit, directs the flow of instructions, execution units, specialized hardware for different tasks. Cache is especially important. It's like the CPU's personal notepad. Instead of asking the RAM for everything, the CPU just stores frequently used data into the cache, so it can just grab it instantly. The L1 cache is the fastest but the smallest. The L2 cache is the bigger but slower one. Now the L3 cache is shared across cores. This hierarchy keeps the CPU running at full speed. Basically, your CPU affects almost everything that your PC does. Game performance, video editing, speed, how fast apps open and how many tasks you can run at once, AI workloads, streaming, encoding, physics, calculations, background processes. It's the command center of your entire system. A strong CPU doesn't just make your PC faster, but it makes it feel smoother. So that's it. If you did like this breakdown on how CPUs work inside of your computer and what they are, please like and subscribe for more future tech tips and for future content. See ya!